Hello everyone. As part of learning generative AI, in the previous sessions we have learned what are transformers, how do they work, what are the extensions and how those extensions are helping it, and what is transfer learning, and how all these concepts are helping us with various models. And as part of that we have learned all these concepts with respect to the case study spell checker, wherein we have seen the baseline spell checker with its limited functionality and how the machine learning concepts, if we are trying to include how best the spell checker is performing, what are the advantages we are gaining, all these concepts we have seen. In today's session we will be talking about what is pre-training of BERT and how do we go for adapting BERT. And in the previous session we have seen the introduction of BERT. It is a bidirectional one which is trying to work with the encoder concept of the transformer. So pre-training of BERT, first of all BERT goes with bidirectional encoder representations, wherein the transformers encoder will be working here in order to generate the hidden states, and it can read through the input tokens from both the directions. That is how it is bidirectional encoder representation. So pre-training of BERT is a very crucial step which will make the model understand the context and learn the language representations. And once we finish through the pre-training of the model, we go for fine-tuning of that, wherein we are allowing the model to perform specific tasks. So this is like whenever you are trying to talk about this, in the pre-training you are allowing the model to learn the complete language, and in the fine-tuning you are asking it to perform a specific task related to the language it has learnt. So this pre-training of BERT consists of two main training objectives. One is the masked language model, the other one is the next sentence prediction. Let us quickly look in detail about these two objectives. First one, masked language model. What do we mean by this? So during pre-training, BERT randomly masks some of the input tokens in the given sentence. Generally they suggest 15%, but definitely this can be customized depending on the task we are performing and the model we are working with. The model's task is now to predict whatever tokens have been masked by BERT, and it has to not only simply predict any random word, but it has to find out a word which is fitting to the context. So understanding context is also very, very important. Say for example, we are trying to give the sentence, the cat sat on the dash. So we have masked the word which is there in the blank. The model has to learn the language and it has to predict the missing word depending on the context. The cat sat on the, right? So generally we expect a rhyming word, mat. So there is nothing going with rhyming, but generally cat sat on the mat. This is what we have kept on learning since we are kids. So for example, if at all I have masked the word mat, the model has to predict depending on the context. So the bidirectional context allows BERT to identify the deeper relationships that are existing between various words of the language it has learned, and it can understand the context and it can try to predict which word do fit into the masked position. Next sentence prediction. In this objective, what is BERT doing is, the BERT is trained to determine whether two sentences are coming contiguously or not, right? So during the training, pairs of sentences are formed, and 50% of the time second sentence is the actual next sentence. 50% of the time how do we give is a random sentence from the given data corpus. So this helps the model to learn what are the relationships that are existing between various sentences and understand the context, and it can perform the tasks like question answering, natural language inferences, etc. Data and training. BERT is typically pre-trained on a huge amount of text data. Generally we make it learn from the Wikipedia and book corpus data set. This contains various language patterns as well as contexts. Then the training process uses a large number of GPUs or TPUs, and it can handle all the computational demands, thereby allowing BERT to learn all the complex features of the language, and it can also learn various contexts. Not only related context, it can also learn various diverse contexts also. And what are the benefits of this pre-training? First one could be generalization, wherein when you are learning from huge amounts of text data, BERT develops a very strong understanding of the language, and later we can ask BERT to do specific applications or fine tuning in order to perform specific applications, which can give you a very good improvement in terms of performance. Transfer learning. Because we are pre-training BERT, this can be easily adjusted to various NLP tasks. This can be easily used in various NLP tasks with minimal input of task specific data, and this approach makes it for developing various robust language models. In terms, once we pre-train BERT, we are using it in order to perform specific tasks which are related to the language. So we can also call it as it is facilitating transfer learning. So how do we adapt BERT? Adapting BERT involves fine tuning the pre-trained BERT model to a specific NLP task. Because BERT is pre-trained on huge amounts of text data, and it has already captured various patterns of the language, it has understood the language, adapting it to perform a specific task of the language becomes very easy. Like you can, once it has learnt, say for example BERT has learnt the complete English language, it becomes very easy for it to perform sentiment analysis, classification of text, question answering related to English language. It becomes very easy for it. What are the steps to adapt BERT? First one, task specific data set. Once it has learnt the complete language, we should provide, if at all needed, we need to give the task specific data in order to perform the NLP task, right? Then input formatting. Prepare the inputs by adding special tokens. Whenever you are trying to work with input data to perform a specific task, special tokens like CLS. This is a token which can be added at the beginning of the input in order to represent the sequence which is used for classification tasks. SEP, this can be used in order to indicate a separator token which will try to separate two sentences one from the other. This can be used when you are working with tasks like question answering. Fine tuning. Once BERT has been pre-trained, the parameters are fine tuned using the task specific input data by training the model on the labeled data set. So thereby BERT adjusts all the weights so that it can perform the tasks which is given based on the pre-trained knowledge it has gained. Evaluation: once the fine tuning is completed, the model can be evaluated for its performance based on various matrices like accuracy, F1 score, precision, various things depending on the task we are working. What are the benefits of fine tuning? Better performance. So this improves the performance metrics of the model. Efficiency, because you are trying to learn a huge language and you are trying to use your knowledge in order to perform a specific task, efficiency of the model is obviously increasing. And you need not again make the model learn the task specific data from the scratch, right? See, whenever I am learning one language completely, say for example, I have learnt English language completely. Now you want me to answer some questions in English, right? For that, do I need to again get complete training of the language from the scratch? Definitely not needed. So we are trying to make the model efficient because it has already got the pre-training. Flexibility, BERT can be easily adapted to various types of NLP tasks with zero or minor changes. So this makes BERT as a powerful tool in order to perform domain specific tasks by taking help of robust language understanding. Case study: sentiment analysis with BERT. So whenever you are trying to work with this, it takes the powerful language understanding capabilities in order to classify what is the sentiment that is involved in a specific text. Sentiment analysis aims at identifying whether a particular comment or response to a post is given positively, negatively, or the particular person is commenting it as neutral, right? So what are the key steps in sentiment analysis using BERT? So first of all, it is to be pre-trained on huge amounts of data, and for sentiment analysis we use the pre-trained model and fine-tune it to perform the task specific sentiment data set. Data preparation: we try to use the specialized tokens like CLS and SEPs in order to separate various types of tokens. BERT is fine-tuned on a sentiment analysis data set where the final classification token representation is used as a feature for classifying the sentiment, right? The model is trained on labeled data, that is supervised learning, adjusting the BERT weights to specialize the sentiment detection. Prediction: after fine tuning, BERT can predict sentiments for new unseen text, and it is identified. BERT is doing very well in case of sentiment analysis, and it is able to classify whether a particular sentiment in a comment to a social network post is positive, negative, or neutral. Contextual understanding: one of the BERT's key advantage in sentiment analysis is it can consider the entire context of a sentence and it can disambiguate all the words. Say for example, good is understood as positive, not good. See, it knows not separately, it knows good separately. So even though it knows good means positive, the moment I am prefixing it with not, it can know that not good is negative, even though the word good has a meaning positive. What are the benefits of BERT for sentiment analysis? It can understand the context, it takes advantages of all the pre-training, and it can handle all the complexities of the language, whether somebody is talking in terms of sarcasm, when somebody is talking in terms of negations, how they are talking, and it can also understand multi-sentence text also. applications, when you want to go through customer reviews, whether they are responding to a specific product positively or negatively, and social media monitoring, wherein people are keeping on responding to posts, and brand sentiment, whether a particular product is going towards positivity or negativity based on customer reviews. So in a summary, BERT, with its pre-training and fine-tuning and the ability to understand the complexities of the language and the ability to understand the context of the language, it is able to give highly effective performance whenever it is performing various real-time classification tasks. Thank you.